An electric motor converts electrical energy to mechanical energy. It powers many objects used in our everyday lives, including fans, washing machines, vacuum cleaners, BART trains, and many more. We use a battery, which gives the motor energy that travels with the coil, paper clips that make coil poles that provide a circuit to the coil, a rubber band that holds up the coil poles, a disc magnet, which is the compass that anchors that the coil uses. We use copper wire coil, which is a circle-shaped copper wire, which will make it spin, and is sanded down on one end. This sanded down end supplies opposite forces, allowing it to spin. Finally, we use sandpaper that we use to sand off one side of the coil that allowed for coil to spin. This diagram shows that the positive side of the battery is the North Pole and the negative side of the battery is the South Pole. The coil spins due to opposite attraction that the magnet repels. Using the right-hand rule, I know that the magnetic field of the coil is pulled towards the North Pole. Magnetic field from the coil is present when there is a conductor, but not present when it is an insulator, since the insulator doesn't cause current or a magnetic field. It is important that the magnetic field were to turn on and off, because if it were not to be turned off, the coil would get stuck to the magnet and not spin. Shown in the force diagram, when the current is not flowing, there's a normal force from the coil to the paperclip and a gravitational force from the coil to Earth. When the current is flowing, there also is a normal force from the coil to the paperclip and a gravitational force from the coil to the Earth. However, there is also a downward magnetic force from the coil to the magnet and an upward magnetic force from the magnet to the coil.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it.